In the world of software development, managing and maintaining code is as crucial as writing it. Version control is essential for software development as it allows multiple developers to collaborate efficiently, tracking and managing changes to the codebase over time. It ensures that every modification is documented, enabling easier identification and resolution of issues, and providing a history of changes for future reference and audits. All modern version control systems facilitate collaboration through a common repository location, hosted either on a server or in the cloud. This provides a centralized code base accessible to all team members. However, there are different approaches to what the centralized source represents. Centralized version control systems maintain a single central repository to manage all changes. This repository acts as the authoritative source for the codebase, where all modifications are stored and tracked. Developers check out files from the central repository, make changes, and then commit those changes back to the central location. Distributed version control systems like Git allow each contributor to have a full copy of the entire repository on their local computer, with the cloud serving as a synchronization and collaboration point. Azure Repos are a set of version control tools provided by Microsoft as part of the Azure DevOps services. Simply put, they offer a location to store your repositories on Microsoft Cloud servers that are integrated with the other DevOps services. Azure Repos are closely tied to an Azure DevOps project. When you create a project, you choose an Azure Repo implementation. The infrastructure for hosting a repository is automatically included, providing a centralized platform for code management and collaboration. This integration allows for easy access to repositories and ensures they are well organized within the comprehensive project management and development workflows. Each project in a DevOps organization can have multiple repositories. DevOps creates a default repo when you create the project, but you can add more if you like. Azure DevOps Repos supports two types of version control systems. Git is the default provider, or you can choose the Team Foundation version control system. Both systems handle all the common repository actions. You can commit and check in code changes, manage its files and folders in the project. You can create new code branches and handle code merges too. Yet they are fundamentally different in their workflow and best practices. Git has become the industry standard for version control. It is a distributed system, which means each developer has a complete copy of the entire source repository on their developer machine. This enables developers to commit changes, view history, perform code diffs, and execute other version control operations locally without needing a network connection. A single developer can work with Git repositories on their local computer. When it's time to collaborate with others or work on a software team, then it is sensible to put a copy of the repository in a shared location. This is known as a Git remote. Team members can work locally and sync with their team by pushing changes to the remote or issuing pull requests for the teammates to review before integrating the changes into the repository. Azure Repos is a hosting service for Git remotes, facilitating this collaborative workflow. A natural question to consider is the role of GitHub. As part of the Microsoft ecosystem, GitHub also offers a set of DevOps services, including serving as a Git repository host. It's a valid question. I'll address this topic later. I have included a video in the last chapter comparing the two services. When talking strictly about Git remotes, there is little difference between Azure Repos and GitHub. Both are suitable for hosting services for Git remotes. You can host your remotes on GitHub and use Azure DevOps for all the other services, or you can keep everything within Azure DevOps. Now let's look at TFVC, which stands for Team Foundation Version Control. It is a centralized client-server system that has been a staple of Microsoft tools for a long time. In a centralized system, the server is in control. It is the source of truth for code in the repository. Typically, team members check out the files needed for work and check in changes back to the server. Historical data is maintained on the server only. Should you use TFVC? While most new projects choose Git, many enterprises continue to use established technologies long after their initial adoption. If your company has code bases in Team Foundation Version Control, you can start using Azure DevOps services while keeping the original repo intact. It's important to note that while TFVC is still supported by Azure DevOps, Microsoft recommends using Git for new projects and is focusing future investment on Git. For this course, I'm using Git. The examples shown in this chapter are simple. If you are new to Git or version control, you can find more comprehensive courses on the LinkedIn Learning site. If you are an experienced Git user, there isn't much to learn. Azure DevOps is simply another place to work with Git remotes. The primary differences show up when you look at the additional tools on the DevOps portal. The way you use Git on the developer computer will not change. This is a rundown on how we'll use Git in the rest of this chapter. Someone on our team creates a repository in the web portal. Individual team members clone the repository to their local computers. A team member creates a branch for new work. One or more people can work on the branch. Team members commit changes to a branch. When the code is ready, a team member submits a pull request. The designated team members review the request and approve and merge the changes back into the repository. A team needs to use version control to manage code changes during development, and code repositories are more useful when available in a centrally accessible location. We've learned that distributed systems like Git offer many advantages for team development, yet distributed systems still benefit from having a central host. There are numerous hosting options available for Git repositories. If you prefer Microsoft hosting, consider using Azure Repos or GitHub. Additionally, if you favor a traditional centralized client-server approach, Azure Repos supports that option as well. The entry point for repositories in a project is here. You click on the project, and then on the sidebar, there's a section called Repos. I click on that, and then I can see the subsections. So when you click on Repos, it opens the File sub-page. And on the File sub-page, you can see all the files that are in this repository. You can see the history of these files, who committed them and when. And if I click on one of these, I can drill down and see details about that commit. There was 143 changed files, and this file had 48 lines of text added. I can also go back to the files and edit the file. So let's say I want to edit this SQL file here and click on that. That opens the SQL file and has an online editor. So I can see the contents, see the history, compare with other versions, and I can also edit the file. And if I make edits here, then I can commit those files directly from the web portal. I don't need to do this from the command line on my developer computer or from any of my IDEs or editors. I'll cancel out of this. There's also the ability to see commits on a separate page. So here's the commits. This graph shows when you split and branch code. That's currently on. I can turn that off here. I can also filter by different criteria or look up commit IDs. There's also the ability to look at pushes and pull requests. Now, I'm the person that created this demo through the demo generator. So I'm listed as the person that did some of these pull requests because that's how the generator works. But let's go back, take a look at pushes. Here are pushes to one of the branches. So once again, I can look at the entire push. Here today, here's another push, and it takes me to the details page. Same with pull requests. I can click here to see the pull requests that are pending. So here's the active pull request. Here's the completed pull requests, abandoned pull requests, and the ones that I specifically have added. I'll talk more about pull requests when I get to the end of this chapter. There's also the ability to add tags. There are no tags in this repository, and there's the ability to look at branches. Now here I can see that there has been several branches. There's the master branch, there's the copyright update branch, there's the adding contact us branch, and I can see who's working on this. I can see the date that it was authored. I can see the ahead behind statistics about this branch, current status, and I can also click on this to go see the files that are in that branch. So that gives you an idea of what you can do in the web portal. So what I want you to see is like most modern Git hosting sites, there are a lot of tools available on the site for working with the files and the repositories. And this is great because there are many members of your teams that aren't actively developing. I'm thinking of some of your dev leads or your managers or PMs. They might want to look at the status of the repo, but they're not actively working with the code. So this gives them a way to examine everything about that repository. Every project can have one or more repositories. Currently in the health clinic project, I only have a single repository. I would like to add an additional repository so that I can have simple examples for the rest of the videos in this chapter. There are several ways to do this. I'm going to click on Repos here in the sidebar and then go to this drop-down and choose Manage Repositories. This shows all the repositories for this project. I only have the one. And when I click on that, I can see the settings for this repository, like whether I allow forks and many other settings in here. And then there's policies for this and permissions for this repository. If I go back to all repositories, I can go to settings. Now I'm setting policies and permissions for any repository that's created in this project. Let's start by looking at settings. There's this relatively new setting in here called default branch name for repositories. So if you don't use master as the name for your default branch, you can choose the name you like here. They're suggesting main, so let's turn this on. That means all new repositories will have this as the starting branch. That looks good. And then I can click here on create. Here I specify the repository type and two other items. But before I get there, let's talk about some other ways we can get here. Let's go back to Health Clinic, Repos, go to this drop down. There's two other ways to create it. I can import an existing repository, or I can click on the plus sign for a new repository. So now that we're in the create dialog, let's talk about these other two options. Of course, I need to create a repository name. Call this one Simple Repo. Now, if you're an experienced Git developer, what I'm talking about for the next minute will be familiar, so please be patient. Adding a README and adding a git ignore. So a README just adds a text file with the RD extension on it, and this will be useful for my demo because it'll have a single file that I can use for editing purposes. And then most projects, you want to have the ability to ignore certain files and not have them placed in the repository. And you put the list of these files in a git ignore file. Currently, I don't have one, but if I want to add one, there's a set of templates available here. The one I typically use for my projects is this one here because I use Visual Studio. Visual Studio. Then it says my repository will be initialized on the main branch with this repository type, this simple name, and it's going to add a README file. That looks good, so let's go. And I get the success message here. I can see that there are two files, one called .getignore that's got all the settings for Visual Studio ignores, and of course the README file. We'll look at a few other Git actions. In this video, I'll look at how to create a branch and use it for your code. I'll be working in Visual Studio Code. I'll be using the simple repo demo, which has this file, and I'll be making some simple changes to this README file. It's a good idea in a software team to create a branch whenever you want to work on new features. That way, you are impacting only that branch and not the main branch of the application. Now, the way you name these branches varies depending on your team conventions. Some teams like to use the name of the feature. Some teams like to use the name of the person creating the branch. I'll use a feature name for this example. Now, to get to the Git tools, I will go here to the Source Control tab. And then you can see there's a number of settings here or features, commits, file history, branches. See, there's only a single branch at the moment. And I can also perform actions by going up to these three dots for more actions and choose things like push or clone or checkout and so on. And what I want to do is go to the branch submenu and choose to create a branch. I'll call this one add header. Press enter. So now I have a branch in my local clone copy. You can see the branch here. There's the add header. It's got a check mark by it that it hasn't been published. It says here it has not been published to Azure DevOps. So if any of my teammates were to go look for this new branch, they wouldn't see it. So let's go ahead and publish that. I'll go back to the branch menu and choose Publish Branch. Then when I hover over this, it says it's up to date with origin add header. No, I don't want to do git fetch, not at the moment. Now let's go verify that that branch is available in the web portal. Over in the portal, I open Simple Repo and then go to this dropdown, which shows me the branches. And I see there's the main branch, which has the tag of default. And then I see my branch. This is the branch I created called add header. And of course, if I'd rather, I can create a new branch here. I could do it on the web, create the branch here. And then I would have to sync my local copy so I get the branch on my dev box. Next step is to make some changes to this file. So I'll edit it in Visual Studio Code. I'll add this header like that, and then I'll save my changes, Control S. And you'll notice that over here in Visual Studio Code, this number 1 appears. There's one pending change. So I click on that. That takes me to this part of the screen, this page, and I can see that there's one change here. So I can right-click on this and choose to stage the changes. I can choose to stash the changes. I can do all the actions here. What I want to do is commit the changes. So the easiest way to do that in Visual Studio Code is just to go up here and add a commit message like that. Then I'll click on this check mark to commit it. That saves it to my local repository. And then the next step is to synchronize with the DevOps server. I have the choice of pushing the data directly to the server or issuing a pull request. And that's what we'll look at in the next couple of videos. At this point, I have my changes on my local repository, but that's the only place where they are located. So I need to push them to the DevOps server, and that gives us the opportunity to talk about the difference. So git push is a git operation, and that allows me to send the contents to any other remotes that I might have from my repository. And then the idea of a pull request is something that was coined by GitHub, and it's also part of DevOps. And this is where I ask other people to pull my pending change into the repository. Here's the workflow. You push to the branch on the remote, and then you take the branch and you do a pull request on the branch into the main branch. So let's do the push first. So I can do that by going to, before I do that, let's switch over to the browser. I'm over here, and I'm in the add header branch. You can see that here, and if I refresh this page, press F5, see the changes aren't here yet in the DevOps server. Now I'll go to Visual Studio Code, I'll go to the source control page, and then I'll click here in the 3 dots, I'll do a push. You can see the status in the lower left. Now I'll switch back to the server. Refresh the page, and there is my change. So at this point, I'm ready to make the pull request from this branch into the main branch. I'm on the portal, and I can see that in this branch, I updated it about 15 minutes ago. And at the top, there's this create pull request. So I can click here to create the pull request. I could also create the pull request in tools like Visual Studio or any other IDEs, but I'll do it here on the web portal. So I'll click here, I choose a title, and I choose a description. At the top, I can see a summary. There's one file that was changed. There's one commit in this pull request. I can use Markdown to add more markup to the description down here. I can also specify work items. If there's a work item that I'm closing, I can choose that from this list. And I can add tags if necessary, but the main thing that I want to add is required reviewers. So I will add Tad as a reviewer. And so he's the one that's going to be responsible for looking at this pull request and deciding whether he wants to pull it. Where is he going to pull it into? Well, you can see that up here, the main branch. Now I can choose other branches. In this case, there's only 2 branches available, but I could say I want to pull this into any of the other branches that are in this repository. So I'm going to pull it into main, or I'm asking Tad to pull it into main. I'm ready. I'll then create. It's marked as an active pull request. And if I go, let's see if I go over here and look at pull requests, I can see there's one pull request created by me and has to be reviewed by Tad. Now we are logged in with Tad's account, and he's working in the Azure DevOps portal. And right now, if you look at pull requests, there's no pull request. That's because he's in a different repository. He's in this My Health Clinic repository. If he switches over to the Simple Repo repository, now he sees there's one pull request that's been assigned to him. So you can see active, completed, abandoned, and the ones that are assigned to me. So I click here. And then you see a screen similar to the one where I created the pull request. So you read the title, the description, You can see information about which files were changed, including the changes that are in that file. You can read that here. You can also do diffs on the values. You can see the updates and commits that are involved. You can go to overview. And one of the most important things about this is, remember, I'm asking other people to review this. And then if it's satisfactory, to pull it into the main branch. Dad can have a conversation with me here. And that's one of the benefits of using tools like DevOps, is that you can have this history affiliated with your work items and this history affiliated with your pull requests and commits. We can have a conversation here. And then when he's satisfied, he can go up here and do one of these actions. He can approve it. He can approve it with suggestions. He can wait for me. He can reject it. Now, in this case, there's only a single reviewer. If there were more than one reviewers, then they would all have to approve it before it gets merged into main. And speaking of merges, one of the issues we occasionally run into when you're writing software and doing pull requests is that there are merge conflicts where there are lines of code that aren't compatible. And so Tad can check this out here on this top where it says no merge conflict. So he knows if he approves this, it's not going to be a problem. So in this case, he'll go up here and choose approve. It says Tad approved the pull request. And now we can go back to pull requests. And it says no pull request for current view. Now let's take a look at it from my perspective. So over on my login, I can see that there's some updated just now. I can click on this. I see that it's been approved. So now I can go ahead and complete this. Or what else are my choices? I can complete, abandon, or mark as draft. So I'm going to choose to complete. And it's asking me here, what do I want to do? What kind of merge do I want to do? So I can do a merge, no fast forward, squash commit, rebase and fast forward, and semi-linear merge. We have lots of choices. The one I need is merge, no fast forward. I also have some other things like, what should we do after merging? Should we delete the add header branch after merging? Yes, we should. So I'll go ahead and complete the merge. So it shows that Walt Richard completed this pull request. And then let's go take a look at branches. There's only a single branch now. So that's your complete workflow for working with a pull request.